Okay, so I made the first video there and then asked you to actually play with some data, try and create your own hash table and see how it worked. Now we're going to move on to open addressed hash tables, which are a different kind of hash table. As a reminder, in hash tables, one of the problems you can have is collisions. Typically, the number of entries in the hash table is small relative to the universe of possible keys. Consequently, most hash functions map some keys to the same position at the table. When two keys map to the same position, we say they collide, and a good hash function minimizes the collisions. That's what we already know from our video earlier today. Sorry, everyone. Okay, earlier I said what would happen if we had a perfectly directly addressed hash table and we wanted to add to it 23, 49 and 3, and we did modulus 10, so I'm sure you remember. What happened is that we ended up putting a chain down and doing a chained hash table. Well, what if I told you that you could not randomly increase the size of your table and it had to use a fixed amount of memory and fixed memory locations? Okay. This is actually the case in some real scenarios. For example, a circuit board with very limited resources, or perhaps a hash table that you think is going to become absolutely huge. Say it was the NHS database as an example. And you didn't want to give it, endless amount of memory. You wanted to give it some idea as to how much memory this would actually take up. Well, that's where open addressed hash tables come in. Open addressed hash tables use the hash function like normal. Now we call that the primary hash function. If a collision occurs, it uses a secondary hash function to resolve that collision. You can actually have tertiary hash functions, so you can have, if it collides again, you go down to the third level, so forth and so on. Mostly, people are doing open addressed hash tables, they have a primary and a secondary, they don't have to go down to the tertiary level. Okay, so back to our example. We've got our directly addressed hash table. Unfortunately, it can no longer be directly addressed. We've got 3 more bits of data we want to add. We want to add 23, 49 and 3. And all of those, if we do our primary hash function on them, which is the key modulus 10, go to indexes that are already used. One possibility is that our secondary hash function could be just to carry on until you find the next free bucket or the next free location within our array. If we did that here, we'd end up with this. So let's go back. 23, okay, we'd do 23 index 10, and then we'd find out that is 3, 23 modulus 10, sorry, find out that is 3, that goes into index 3, that's full, we can't use it. So we go across to 4, the next index, it's full, we can't use it. So actually we'd end up putting 23 at index 5. Okay, 49, we do modulus 10 to get our hash value, and that is 9. We see that 9 is used. 39, there isn't a next value in this case, so we loop round and 49 goes in 0. Right, now we've got 23 and 49 in. Pause there and you work out where 3 is going to go. Okay, hopefully you paused, you've come back, and you correctly worked out that 3 was going to go in location 7. Now, how would you find an element? Well, let's imagine that I'm looking for 3. Okay, let's say I'm looking for 3. I do my hash function, my primary hash function. So that's 3 modulus 10, which is 3. I look in index 3 and see it contains 13. So now I know that I have to go to my secondary hash function and see that if I can find the 3 from there. And my secondary hash function is that I scan along the boxes. So I check 4 and that's 14. That's full, so I know I've got to carry on. 5, 23, that's full, so I know I've got to carry on. 6, 16, that's full, so I've got to carry on. And then I find my 3. Okay, so I'm scanning through using my secondary hash function. What about if I was looking for 14? Well, which is my primary hash function, which is modulus 10, gives me 4, 14's actually there, so I don't have to do any scanning through that time. What about if I am looking for 59? Okay, 59 is modulus 10 is 9, so I go to location 9, 39, that's not the correct number. I then go to location 0 because I loop round, I find that's 49, so that's not the correct number, and then I find an empty box. And because I know that my secondary hash function will carry on filling up along, the first time that I find an empty box I can say it's not there. Okay, what I want you to do is choose 4 numbers, maybe 2 that are there and 2 that are not in this hash table, and just work through and work out how you would find out if they're in this table. Remember, your primary hash function is modulus 10, your secondary hash function is used as the next index along that's free. Pause there, do that, and then come back. Okay, hopefully you're back and you got that to work. The complexity of an open address hash table. So you can insert a node in constant time, you can remove a node in constant time, you can look up a node in the length of time it takes you to look at every node in the table until you find an empty node. So if we go back to this case here, imagine I was looking for 63. I'm actually going to have to look through just about every array in the table until I get to that one blank one there. So I'm going to look up 8 of the 10 things to try and find that. So that's actually quite slow. So in general, when we're using open address hash tables, we want them to be a lot larger than the amount of data. We want them to be a lot of spaces so that we know that we don't have to carry on looking, and that makes it a lot more efficient to use. Okay, so challenge question. I've given you a hash table of length 10. I want you to come up with a good hash function for hashing 8 strings. Remember, this is a way of mapping a string to an integer between 0 and 9, and also a way to deal with collisions. So a primary hash function, the first one you use, a secondary hash function, the one you use with collisions. And your data is the same as you've done already. So I'll leave you to do that in your class, and also I will give you a Java task to do. A Java task to do. Sorry if I just panicked anybody. Okay, I hope you enjoy that.